All right, let's go ahead and do some in-cam upgrades.
All right, everybody, it's time to put on our detective hats. The case we're cracking today, the Code of Cost Variances. Now, this is a seriously powerful tool that managers use to figure out if their business is actually running the way it's supposed to, or if something somewhere has gone completely off the rails. It really all boils down to comparing what you thought was going to happen with what actually went down. So, ready? Let's get into it.
So here's the plan for our investigation. First up, we'll see why standards are so important. Think of it as our baseline evidence. Then, we'll start spotting the first clues. That's where variances come in. From there, we'll follow the leads, digging into materials and labor. After that, we're going to tackle the trickiest part, the overhead puzzle. And we'll wrap it all up by closing the case and seeing how all this detective work leads to real action.
Okay, so first things first. Any good detective will tell you you need a baseline. You need to know what was supposed to happen before you can figure out what went wrong. And in business, that's exactly what standards are for. I mean, think about it. Without a standard, how do you even know if you're doing well or badly or just okay? It's the yardstick. It's the normal that we measure everything else against.
So, what exactly is a standard cost? The easiest way to think about it is it's the perfect world cost. It's what we expect it to cost to make one single unit of our product. And this isn't just a number we pull out of thin air, no way. It's a super carefully calculated figure that includes all the direct materials, the direct labor, and even a slice of the factory's overhead. Basically, it's the bullseye we're aiming for.
Let's make this a little more concrete, shall we? For our investigation today, let's pretend we're a company that makes widgets. Now, after a whole lot of careful analysis, we've figured out that in a perfect world, one of our widgets should cost exactly $6.23 to make. And again, that's not a guess, it's a benchmark we've built based on what we expect to pay for materials, how efficient our workers should be, all that stuff. So remember this number, $6.23. It's going to be our North Star for this whole case.
And you know that $6.23 figure? It's way more powerful than it looks. It's not just some boring accounting number. It's a tool. It helps managers plan and keep things under control. It gets the entire team, from the factory floor to the top office, thinking about costs. It even helps the sales team set prices on the fly. And, this is a big one, it lets them use something called management by exception, which we'll talk more about later. Really, standards are the bedrock of running a tight ship.
Okay, so our benchmark is set. Now, the real investigation begins. Let's say we've just finished making a batch of widgets, and the real actual numbers are in. And guess what? Our actual cost doesn't match our standard cost. Bam! That's our first clue. And that difference, that gap between what we expected and what happened, has a name. It's called a variance.
So yeah, a variance is literally just that, the gap between what we planned to spend and what we really spent. Let's go back to our widget. If the standard was $6.23, but it actually cost us $6.50 to make one, well, we've got a variance of 27 cents. And that 27 cents, my friends, is our first big clue that something didn't go according to plan.
So is this a good clue or a bad clue? Well, on the surface, it seems pretty straightforward, right? If our actual cost is higher than the standard, like that 27-cent difference, we call that an unfavorable variance. Makes sense. We spent more than we wanted to. That's a problem. And if our actual cost came in lower than the standard, maybe at $6.10, that's a favorable variance, a potential win. But here's where the real detective work comes in. Because as we're about to find out, even a so-called good clue can sometimes lead you down the wrong path.
Look, knowing we have a 27-cent unfavorable variance is great, but it doesn't close the case, not even close. It's like a detective arriving at a crime scene and just saying, yep, something happened here. We don't know who, what, or why. To find the real story, the root cause, we have to break that total number down and start following the individual leads.
And here's the key. That 27 cents is not one single thing. It's actually a combination of three main suspects. Part of that difference could be from the materials we bought. Part of it could be from our labor costs, and part of it could be from all that factory overhead stuff. To get to the bottom of this, we've got to interrogate each of these suspects one by one.
And when we're looking at materials and labor, our investigation map gets really simple. We're basically asking two core questions. Question 1, did we pay a different price for it than we expected? And question 2, did we use a different amount, a different quantity than we planned? That's it. For materials and labor, it almost always boils down to one of those two things, price or quantity.
So let's follow that first lead, the price variance. This is all about the money we paid out. Did we pay too much? Or did we maybe get a good deal? If we're talking about materials, our investigation immediately turns to the purchasing department, right? Did they negotiate well, or did our supplier jack up the prices? And if we're talking about labor, we're looking at HR or whoever does the scheduling. Did we end up having to use a more senior, more expensive employee for a job that a junior person was supposed to do?
Now for the second lead, the quantity variance. This one's also called the efficiency variance, and it asks a different question. Did we use too much of something, or were we super efficient and used less? This clue almost always points us directly to the factory floor, to the production department. Were the workers on top of their game? Was there a bunch of wasted material? Maybe a machine was acting up and chewing through raw materials? This is all about how efficiently we used our resources. And here you can see some classic culprits, right? An unfavorable materials price variance could be something out of our control, like a supplier hiking their prices. But an unfavorable quantity variance? That could be on us. Maybe a machine is calibrated wrong, or new workers are making mistakes. But here's where it gets really interesting, where the plot thickens. What if we got a favorable price variance because purchasing bought some super cheap materials? Yay, we saved money! But then, what if that cheap material was junk and caused a huge unfavorable quantity variance because half of it had to be thrown out as waste? See? These clues are almost always connected. You have to look at how they tell a story together.
All right, we've grilled our first two suspects, materials and labor. Now it's time for the final boss, the most complex character in this whole mystery, manufacturing overhead. This is all the other stuff needed to keep the factory lights on, literally. Electricity, supervisors' salaries, factory rent, you name it. So why is overhead such a puzzle? Well, it's because it's not just one thing. It's actually a mashup of two totally different kinds of costs. On one hand, you've got your variable costs. Think of the electricity that runs the machines. The more widgets you make, the more electricity you use. Simple. But then you have your fixed costs, like the rent for the factory building. That rent costs the same whether you make one widget or a million widgets. And because these two costs behave so differently, we have to pull them apart to analyze them properly. Okay, let's use this to break it down. Don't worry, we'll go slow. Look at the top row, variable overhead. Just like with labor, we have a spending variance. Did we spend more per hour on things like indirect supplies than we thought we would? And we also have an efficiency variance. Were our teams efficient with their time, or did they run the machines for too long? Okay, now shift your eyes to the fixed overhead row. We still have a spending variance. Did our property taxes go up unexpectedly? But that middle box is empty, and we have a new one on the right, the volume variance. This one is super important. It basically asks, did we use our factory as much as we planned to? Think of it this way. If your rent is $10,000 and you plan to make 10,000 widgets, that's $1 of rent per widget. But if you only make 8,000 widgets, now each one has to absorb more of that rent. That's an unfavorable volume variance, and it's all about how well you utilized your capacity. Now, I know the math here can get a little hairy, but you don't need to be an accountant to get the gist. Just keep these 4 key rules in your detective's notebook. First, everything, and I mean everything, is based on standard hours allowed. That's just a fancy way of saying the time it should have taken to make what you actually made. It keeps the comparison fair. Second, there's something called a budget variance, which is really just a combo of a few different things. Third, and tattoo this one on your brain, the volume variance we just talked about is only for fixed overhead. And finally, when you add it all up, the total difference is what the pros call over or under applied overhead. Just some key rules of the road. All right, we did it. We gathered the clues. We've calculated all our variances, price, quantity, spending, volume, the whole shebang. The puzzle is solved. But wait, our job as detectives isn't actually over. Because gathering clues is pointless if you don't do something with them. The whole point of this entire investigation is to turn what we've learned into action. And that brings us right back to that idea I mentioned earlier, management by exception. Think about it. A manager is crazy busy. They can't possibly keep an eye on every single thing happening every single second. What variance reports do is act like a spotlight. They let the manager completely ignore all the stuff that's running smoothly, just as planned, and shine a bright light only on the things that are out of whack, the big problems, or maybe even the big unexpected wins. So what does this look like in the real world? Well, the final report, the case file, has to be delivered fast. There's no time to waste. The goal is to get this info into the hands of the right manager, like yesterday, so they can actually fix the problem. If we're wasting a ton of materials, the production manager needs to know now, not in a report next month. And what about the CEO, top management? They're not going to get bogged down in the tiny details. They're just going to look at the big stuff, the really significant variances that might affect the whole company. And that, right there, is the single most important thing to remember from our investigation today. This whole process, variance analysis, it isn't just a boring accounting exercise to fill out spreadsheets. It's a real-deal management tool for problem solving. It's about looking at the numbers and constantly asking, why? Why did that happen? and then using the answers you find to run the business better, smarter, and a whole lot more efficiently.
So I'm going to leave you with one final puzzle to think about. We're always told favorable is good, unfavorable is bad. But is it really that simple? Imagine your purchasing manager comes in chest all puffed out because they got a massive favorable price variance by finding a new, cheaper supplier for materials. Everyone high fives. But then, what if that cheaper material is so low quality that it causes machines to jam and workers to throw away half of it, leading to a huge, disastrous, unfavorable quantity variance on the factory floor? Who's the hero now? It just goes to show you, a good detective knows that no clue exists in a vacuum. You always have to look at the whole picture.